Hello everyone, my name is Mykhailenko. I am going to talk about economic aspects of introducing pumped storage hydroelectric power plants into the mine dewatering system for distributed power generation. Improvement of energy efficiency in mining production aims to enhance competitiveness of Ukrainian enterprises on global and domestic markets. Introduction of additional generation facilities into the enterprise power system is able to reduce costs when purchasing electric power from external distribution operators. Technological facilities located directly in or next to mine workings can be viewed as a method of producing power. The mine water drainage system is one of such facilities, and its energy potential is not currently used to the fullest. To increase efficiently of an energy resource, a mini pumped storage hydroelectric power plants, mini PHPPs, are suggested to be installed in sections of mine water drainage. Thus, mine waters can be discharged backward either from upper horizons or surface to lower horizons, thus generation power via hydroturbines. Efficiency of introduction of mini PHPPs for combined power supply of mine consumers is considered by taking water drainage of Rodina mine as an example. When conducting the research, three designs of distributed generation system via mini PHPPs are considered. For each system design, a comparative analysis is performed with two options of power consumption considered. First, from the industrial power grid supplied by external power system. Second, combined power supply of the grid and mini PHPPs. The net present value of the system and levelized cost of energy are used as criterions for comparing efficiency of the above two options. Computational experiments are conducted by using MATLAB. Calculation of mini PHPPs option considered investment for purchasing a hydroturbine and various expenses for scheduled and preventive repair and maintenance works. Power generation of mini PHPPs is performed at the nominal hydrostatic pressure. The cost of power received from the power supplying company for first category industrial, non-household power consumers, besides power costs during peak hours, are also modeled. In figures, there is NPVs of the power system for different conditions when basic power tariff is used. The graphs indicate that the low power consumption and the hydroturbine water consumption close to the nominal value and the minimal power consumption, the NPV of the system is determined by operating cost of the mini PHPP. This is due to the fact that power generation of the hydroturbine fully satisfies the current power consumption, so the purchase of power from the external power grid of the distribution operator is not carried out. Additionally, there is dependence of the NPV of the combined power system on hydroturbine water consumption and power consumption. There are also determined application areas of parameters within which it's advisable to use a particular design. The area of effective application of combined power supply system with its own distributed generation facilities within the considered change of parameters is 17.2%. These are the most unfavorable conditions for modernization of power system, as they totally indicates the lowest area of the distributed generation applied, making it inefficient. Application of the tariff for peak hours is expected to increase efficiency of the combined power supply system with single hydroturbine-based mini PHPP on the 500 meter level. This is due to increased cost for power purchased from external power grid are higher prices. At the same time, expenses for purchasing, maintaining and repairing a hydro generator remain unchanged as compared to basic tariff. The dependence graph shows a more intensive increase in the NPV with increased power consumption and reduced hydroturbine water consumption. The application area of the distributed generation system with mini PSH-PPs increased to 90.6% compared to the basic tariff. At the final stage, efficiency of introducing the distributed generation system with mini PSH-PPs on the 500 and 940 meter levels of Rodina mine is considered, as this option has the energy potential of water discharge from several mines. 4 storage pumps are investigated, 2 on each level. The obtained data indicates that the NPV of the mine power system with mini PSH-PP is growing significantly. Analysis of the components of the NPV system with combined power supply indicates a greater increase in the fraction of NPV of mini PSH-PPs in the NPV of all system. In this case, the level of power generation sufficient for PHI's power supply is provided in all the cases for middle and high power consumption and low water flow rates of hydroturbine. The dependence graph shows an increase in the system NPV in the area of increasing power consumption. The optimal application area of the power system of with PSH-PP is 50.6%. With the peak tariff in action, the NPV of proposed power system with mini PSH-PP is lower than the NPV of the system in which consumers are supplied only from external grid with middle and high power consumption and water flow rates 0.15 cubic meter per second and 0.23 cubic meter per second. The dependence graph in figure shows a more intensive increase in the NPV with increased power consumption and reduced hydroturbine water consumption. This significantly expands the application area of the distributed generation power system compared to the previous case. In this worth nothing that comparing the efficiency area of the system with 4 storage pumps with the corresponding areas with 1 or 2 hydroturbines installed, this one appears to be largest and makes 72.8%. It means that despite high capital cost for purchasing generation equipment and its subsequent maintenance, this option is the best in terms of power supply with varied power consumption and hydroturbine water flow rates. Application of mining enterprises drainage system with hydroturbine-based mini PSH-PPs of various capacity to produce an additional power enables increasing efficiency of power supply to consumers by reducing the cost of purchasing power from external grid. This also reduces the cost of final products and increases their competitiveness. Analysis of different design of the Kryvyi Rodina mine power system, it reveals that mini PSH-PPs are efficient when generating capacity is close to the installed capacity of the consumers. The system with mini PSH-PPs for storage pump on the 500 meters and 940 meter levels appears to be the best option for the peak tariff. It reveals the lowest value of the NPV in conditions close to nominal and highest application area. However, the analysis of NPV indicates that under conditions close to the nominal, the use of mini PSH-PPs with single hydroturbine has the highest reduced cost due to low generation, this making it inexpensive to use compared to other designs. With the basic tariff, it is advisable to use as the distributed generation system with only 2 storage pumps installed on 500 meter levels, as it has the highest efficiency among of studied designs. Thus, the generating economic effect can be achieved by introducing mini PSHPP system consisting of 4 hydroturbines, 2 of which are used during the basic tariff house, and when the peak tariff is used, all units are involved. Such balancing should be introduced by means of power supply control system of main consumers. Thank you for your attention.